Okay, so we're going to run Dijkstra's algorithm without rewriting everything over and over and over again. So we are supposed to find the shortest path from A to G. And so G is that ending vertex in our path. So that's where we're going to start. We're going to label it 0. We're going to mark that vertex as current. And then we're going to work to any vertex adjacent to G. We're going to mark it with letter G. That's where we've come from, and how long or how far the distance it took us to get there. So vertex E coming from G is 7 units away, and vertex F coming from G is 6 units away. We're now done with vertex G. So we will cross that off. We will look at the two labels we have applied, G7 and G6. 6 is the shorter distance, and so F is now our current vertex, the one with distance 6. Now we look at every vertex adjacent to F. So I'm going to work kind of from the bottom up. So vertex C is adjacent. That's an additional 5 spaces. So we could get to C going through F at a total distance of 6 plus 5 is 11. D is an additional 4 as a distance coming through F, and so that's a total of 10. So F10 is the total. Vertex E going straight up, we're already at a distance of 6 at vertex F. Adding 2 more would give us 8. That is not an improvement on a distance of 7. And then vertex G, which is also adjacent to F, has been visited. It's done. So we're not going to go back there. So at this point, we are finished with vertex F, and we can cross that one off. Looking at our remaining labels, a distance of 11, 10, and 7. 7 is our next fastest. And so vertex E with a distance of 7 is our new current vertex. Now going from vertex E, we could, excuse me, looking at everything that's adjacent, we could go to G, but we've already been there. We could go to F, but we've already been there, okay? We could go to vertex D at an additional 2 units. We've gone 7 so far. An additional 2 would give us a total of 9. That is an improvement over our current distance of 10. So we're going to cross off the distance of 10. We're going to replace it with a distance of 9. And that's if we would visit vertex E next, okay? Also from vertex E, vertex B is adjacent. B doesn't have a label at all. So if we're at a distance of 7 at vertex E and we go another 6, that's a total distance of 13 going through vertex E. Okay, now we're done with vertex E. We look at our labels, 13, 9, and 11. 9 is our shortest, so vertex D is our next vertex. Now again, we're not going to go looking at adjacent vertices. We're not going to go back to E. We're done. We're not going to go back to F. We're done. Okay. We can go from D to C at an additional 2 units, but notice that that's also a total of an 11. That is not an improvement, so there's no need to cross it out. We're already at 11. We only cross it out and replace it if it does better. To get from D, which has a distance of 9, to B, we can go 3 units. That gives us 12. That is an improvement. So we're going to cross off the E13 and replace it with a D12. Now we're done with vertex D, so I'm going to cross that off. Looking at our labels, we've got a 12 up at vertex B and an 11 at vertex C. The 11 is the shortest, so C is our current new vertex. Again, we're not going to go backwards to D. It's already crossed out. We're done. We're not going to go back to F. It's crossed out. We're done. Our only choice is to move on to vertex A at an additional 4 units. So 11 plus 4 is 15. If we go to vertex C, there's nowhere else we can go. So we now cross off vertex C. We're finished. And looking at the two labels at vertex A and at vertex B, the 12 is the shorter of the two. So vertex B is now our current vertex. Again, we're not going to go back to E or D or E or D. We're done with both of those. Our only choice is to look to go to A. At B, we're at a distance of 12. If we add one more to that, that's 13. That is an improvement. So from B, we can get a total of 13. Okay, now we're done with vertex B, and notice we're at A and there's nowhere else to go. So we've completed our algorithm, and now what we need to do, again, is follow this through to find out where it is we've been. So we start at vertex A, okay, that's our starting vertex, and that says we go to B next, looking at the label. So we go to B next, and that says go to D after that. So we go to D, and then that says go to E. So we go up here to E, and then that says go to G. Okay, so there's our path that we're going to follow. So we go from A, let me turn off the highlighter and turn back on the pen. So we go from A to B to D to E to G. And the weight, or the total distance, is again this weight of that final label there with a weight of 13. A, B, D, E, G with a weight of 13. And that's following those labels to get back through where it is you've come from.